Hi, in this short lecture, I will talk about the Python list and dictionary performance. We have been using the list and dictionary, especially list, for many weeks now. There are many the common list operation includes indexing with the bracket index operator, updating element in the list, growing a list. And how do you grow a list? You can use the plus, the list concatenation operator, or using the list append. You can also grow a list using list comprehension and using list converter function and range function. And to do the performance, I'm going to use something called time_it module to time the algorithm. With the time_it module, I will from time_it I report I import the timer. So I have four different functions. Each of them do the same thing, but just do it differently. First one using the append or the concatenation operator to grow a list. Second one using the list append. Third using the list comprehension to create a list. And fourth using the range and list converter function to convert a range into a list. And then the timing module is designed to allow Python developer to make cross-platform timing measurement by running functions in a consistent environment and using timing mechanisms that are similar to other operating systems. Create a timer object parameter has two things. You need a Python statement that you want to time, and the statement that will run once it's set up. And the timing module will then time how long it takes to execute the statement some number of times. It doesn't only run one time, it runs some number of times. And by default, it actually runs million times. So basically, the time that it give you, you can divide by million, which is more like a microsecond. And you can set time it to run instead of a million times by default, you can set to run only 1,000 times. Right? The yeah, because by default the time it run the function million time, if it take say 2 seconds total to run that statement million time, you can think about it would take 2 microseconds to run only one time. So in this example here, I only run 1,000 times instead of a million. Then that's the reason I put millisecond here. Because if I run whatever time you give me, it will be millisecond to do it only once. And if I run this, let's go to the PyCharm. This is a list, and here is my setup for all four timer, and I time it and run that for each of them. And when I run this, it will take some time here. The concatenation operator, the one with the plus, it took about 2.5 seconds, 2.5 milliseconds for each operation. Append, it took about 0.13 milliseconds. List comprehension, even faster, almost twice as fast, 0.065 seconds. And the list range function, even faster, only took about 0.03 milliseconds for each operation. I run this timer with the 1,000 iteration, so the average I would be like millisecond. And from this number here, which one do you think is better? And better in what sense? Well, by looking at this, they all give you the same list result. The list range function will give you the fastest in this scenario. What about the list pop and pop n performance? We call if you have a list, say a list equal to say 1, 2, and 3. If you do a list dot pop, pop, it will delete the last guy. If you do a list dot pop, say 1, it will delete, in this case, the second guy. We remember the index start at 0. So which one would be faster? So I also set up a code to run pop 0 and pop, which is pop the last item. Popping the first item versus the popping the last item. And I run that with a different number of lists. So let's run this. It will take more than a few seconds to run this. For 1,000,000, 2,000,000, it's taking longer and longer here now. 3,000,000. But do you see some trend here at the time, at the number, the size grow? What trend do you see here? 5,000,000, 4,000,000, 6,000,000. What trend do you see? For both pop 0 and pop in the last item. And you probably notice that pop in the last item, the time is pretty much constant. It's taking really no time. But pop in the first item, the time taking longer and longer as n, the size get bigger and bigger. The 9 second to almost 10 second, the 9,000,000 almost took 10 seconds. That means the 10 millions probably took you take another second or so. I think you can conclude that if the n increase at the size increase, the time it takes to do pop 0 increases. The increase doesn't look like a linear. The increase, it doesn't look like a linear, but it does increase over time, over the size of the number. So what you can conclude about pop 0? Well, pop 0 is not constant. I can already conclude that. I can tell if this is um, linear or not, but it looks almost linear. From this example I did a while back, it looked pretty linear. For the pop, it's a constant. It's a constant running time. And for list, these are the big O efficiency for the list. The index assignment, append, and pop, those are constant. Pop I, insert at I, del, iteration, and in, those are linear. Slice, those are OK. The K would mean the number of items between X and Y. Delete with the slice is a M plus K. Reverse is a linear. Concatenate is a K, meaning depending on how many you concatenate. Sort is a N log N, and multiply is a NK. If I multiply something by the list, you do everything to the list by N times. What about dictionary? Dictionary, if you recall, using key value pair. And we do not use index to look up a particular value with a particular key. So given this setup here, I am going to insert something to a dictionary and then try to read them out and look at the performance. I have some random number in the dictionary and look at the performance of the dictionary. And if I run this, 1 is a list. The list time is a time it or the with the number thousand. What do you see about the list time and the dictionary time? Well, the dictionary time is pretty much constant, but the list time grow as the list get bigger and bigger, and the growth seems to be linear, about 1.1 second each time for each million on my computer. Your computer might have different number. So dictionary, as you can see, mostly constant. So this is constant, and this one have O n. As n increases, so is the time. And for dictionary performance, everything we need is a constant time except for copy and iteration. And that understood why, because for copying, you had to go through every single item in the dictionary. So that's a ON. It's a linear. Iteration, same thing. I had to go through every single item in the dictionary. So it is ON.